This is start. Oh, it's recording. Nice. Wonderful. So anything on the screen is going to be recorded. Yeah, so the reason why I'm recording is I'm going to be uploading a series to the internet called AS Cambridge Computer Science. And in the curriculum, that's topic 2.1, okay? But we're in Unit 3 because I cut these into smaller pieces. It's more understandable for our class, okay? And so the idea is, this is the PowerPoints. Today we're going to learn about network topologies, or what is a network, okay? And then later we'll actually build a network together, okay? It's a really fun topic. I've done this previously where we set up a router, you connect your laptops, and we make a game, a networking game. So you learn about IP addresses, you learn about the hardware, and things like that. So let's do it. In your notes, it's the same thing. What I expect is, I'm just going to write here, 3.1 networks. Okay? And then put down today's date. What is today's date?
11/27.
It's November. Now, I'm just gonna, I can zoom out here, which is nice. Today's November the 27th. Okay? So, is green okay? Or do you want me to change the color?
Okay.
Okay? Well, I'll go into this, maybe if you want black or something, you can tell me what is, I think maybe black's easier to see, is it, Uma? Oh yeah.
But there's something important, you can change the color that I have.
Yeah, that's right.
I also have a color.
Yes, exactly. Okay, really cool. So, in here, the very first thing is, what is a network? And the problem with studying from PowerPoints, your teacher probably in math class or what have you, they have a PowerPoint. And the problem with PowerPoint is there's too much information, okay? And you forget. And so that's why I always encourage you to have a notebook. Because your textbook is so thick. And if you can write down, you don't need to write down everything, but just the highlighted information. Okay?
Yes.
These are like the cheat sheet or the codes, and this is called codifying information. Because when you write down something, it's going to be more in your brain about how you understand it. You don't need to copy down everything, you just need to write down what is important. And that's going to help you to recall. But if we're just listening, if we're just using our ears, you're not going to learn and remember as well. Because on the exam, you have to write. Okay? And so, have your notebook. Okay? Do you have a notebook, Uma? Or you can use your iPad. Please grab a notebook or iPad, that's fine. Something to write with. Okay? And what you're going to do is just write down the things that I read on the side. And again, if I'm writing too fast, these PowerPoints are on OneNote, okay? And these lessons are being recorded so that you can see them. Okay, so what you have to do is, first we have to know what is a network. What is a network?
Used for go on the internet.
Okay, but I need it more clear. What are the minimum requirements of a network?
I remember I read yesterday, let me check.
Wendy, what is the minimum requirement of a network?
Two or more computer devices are connected together.
Yeah, when two or more computers are connected. Put the definition in your own words. Do not copy the textbook. When we were doing the vocabulary, I didn't, lots of students were just copying definitions. Do not copy definition. put it in your own words. This is Mr. Newson's words. Put it in your own words as you write. You can write Chinese as well so that you fully understand. Okay? It's because this is called simplifying the PowerPoint, simplifying the information, making it more concrete. Okay, now there's a special name for this. The name for this network, this is the smallest network. The smallest network you can have are 2 computers. Okay? If you only have 2 computers, okay? We have a PC here and a PC here connected. This is called peer-to-peer. Just like how you guys are peers, students. It's like student to student. Okay? And the connection, what we could have basically this connection, it could be a wire, it could be Ethernet.
So what's the peer-to-peer?
Peer-to-peer just means computer to computer.
Oh.
Yeah.
Okay.
There is no hardware. What happens is in here you have a NIC card, a network interface card, and you use a crossover wire, okay? Because when you're communicating, you have a TX and a RX signal, okay? And basically the minimum wires that you need is like USB. USB, TX is transmit. That's sending the signal. And then you have RX is receive. Okay? And when you have a peer-to-peer network, you have a TX and an RX on one computer, and you have a TX and an RX on another computer. And you actually have to cross over the wires. This is called a crossover wire, and you can do that with an Ethernet cable. And you do this if you don't have a router in the middle. Usually you have a device in the middle called a router.
What's TX?
Transmit, send.
Oh.
And RX means to receive. So this guy is going to send the signal. It's going to come to the receive pin on the NIC card. Okay?
Okay.
And then we can talk. The minimum requirement of network communication is basically 4 lines. Okay? Because in here you also need to have a ground. You need to have a ground, and then you need to have a voltage like 5 volts. 5 volts here. Okay? This is like USB, Universal Serial Bus. Okay? And we will talk more in detail about how data is sent. But this is the basic idea. The minimum amount of wires that you need are 4, where you have a ground, you have a VCC, which is the positive rail, and then you have a transmit and receive wire. And this is known as USB, but the Ethernet cables have 8, and they have twisted pair. They have some wires that are twisted. And we'll talk about that. I'm just giving you an overview of how data is transmitted. Okay? Clear? Network, how many computers do you need, Wendy?
At least 2.
You need at least 2. Uma, how many wires do you need for a USB connection? How many wires does a USB have? When you plug a USB device, how many wires do you need? Yeah, when you connect with a USB, and you know what a USB is? The USB the drive that we plugged into the computer, how many wires do you need for that signal to talk between 2 computers? We need,
Well, 1 cable, but
inside the cable has how many wires? In this case, you need to have 4. You need to have power, you need to have ground, TX and RX. Okay? 4 wires is the minimum requirement for peer-to-peer communication. Okay? But Ethernet uses 8 wires. Okay? It uses 8 wires. So let's continue on. We're going to watch a quick explanation about how all these things work together. Oh my goodness, this is a hyperlink. I'm going to skip the video, okay? Because later I'm going to have to put hyperlinks inside my OneNote, okay? I'm learning how to use OneNote here. Cool. Continuing on your note, we have 2 basic types of networks. One is called LAN and one's called WAN. And this was part of your homework yesterday. What does LAN stand for, Ted? What does This was part of your homework yesterday. What was LAN? Yeah, sure. Yes, and in English, L stands for local area network.
Yeah.
Local means close. It means within a school, within a classroom. That's called local.
WAS students.
That's right. A school is a LAN. It's a local area network. And what is a WAN, Wendy?
Wide area network.
It's a wide area network. Okay? So let's do some examples. For example, a school network has several LANs. Maybe you have the IT room, you have the different offices, they're all connected to central, they would be router racks, okay? Or there'll be switches, okay? They'll be using a switch, and we'll learn about the different hardware as well.
So will that internet be limited what you can do?
This is how computers are connected to the network. It's not going to limit you, it's showing you how things are connected.
I mean like you want to watch video or play games, this internet will not allow.
No, this is something else. Wide area network, for example, is like a campus. It could be downtown Shinjuku, right? Where you have, it's a large geographical area. For example, a town, a city, something bigger outside. Okay? Here's what an example of a LAN looks like. Usually what happens is you have a central device, like a switch or a hub, and then it's connected to your different PCs. Okay? And a WAN, let me just scroll down here. A WAN, it connects through the internet. You can have a different city, a different campus, a different building. For example, you have a university, you have the different buildings. That's more like a wide area network. Okay, it takes more area. Okay. So you need to know the difference between, this is important, you need to know the definition and some examples what he would look like. A LAN and WAN. So let's look at this. why do we have two different things? I'm just going to highlight what are the key characteristics and benefits of a WAN. So a WAN, it uses a large area. Okay? And why is this beneficial? It means that you could have a job on remote computers. If we did not have a WAN, it means that we would have to use USBs to transmit data, right? Or we would have to have portable hard drives. But since we have a wide area connection, I can be in another city and I can connect to my computer at the office. I go through the internet, I go through different servers, different routers, and I can access remotely information on different servers. I can go to web pages, okay? WAN enables, for example, web pages. Web pages are stored on servers, okay? If I did not have a WAN, I wouldn't have the internet, okay? A WAN allows me to connect to the internet, okay? It's basically the internet. If I didn't have a wide area network, we wouldn't be able to connect from A to B because we need to go through a WAN, wide area. Some other key benefits. A LAN can actually save money is because when I go into when I go onto the WAN, usually we have servers that are rented, okay? The wires and the hardware are rented and shared, okay? For example, in Canada, we have a company called Bell Canada, and they own most of the transmission wires. In China, they use China Mobile and Telecom. And they'll have some companies that own cell phone towers. Okay? Let me just change the color here. So you have some cell phone towers, and you can actually, different companies will rent these towers. For example, we have a cell phone tower. And you can actually rent to send the data and share these hardware devices. Okay? So a key benefit of WAN is you don't need dedicated hardware, you can rent. And that can save you money. I just asked if you don't have the thing in your ear. Thank you. I know, please, thank you.
So what's the people you join there?
This is not a people, this is a cell phone tower. Uma, thank you. Thank you. Thank you.
So what's the cell phone tower? What is it?
Cell phone tower is when you're sending a signal to outside the school, you'll see that there's those high towers and they have antennas and they basically send out the signal. Okay, that's called a cell phone tower, or you could call it an internet tower.
I know. So is this the reason about in our school area the signal was very bad? Is this the reason?
No. That's to do with a router. It's a little bit different. So a key other benefit is you can remotely access the information. That's really good. Now, what are the key benefits of a LAN? Well, LAN, a key difference is you have to own the hardware. I'm going to scroll down. And a local area network, basically, at the very center, either you have a switch, usually you have a switch, and you have your different computers connected to the switch. And then the switch connects to A modem. The modem is from your cell phone company, and then that's your internet service provider. Okay, so you have a PC here, a PC here, and they have different IP addresses, and you'll have to, oh, we also have a router in here. These days, if it's a small one, you could actually, instead of a switch, a router. You could have a router, okay? And they connect and they understand what the IP address is. So that when you get data from the internet, this comes from the WAN, outside WAN. Connect to your modem. It can go onto the cell phone towers, it can use the internet towers, and then your switch will determine which PC to give it based on the IP address. Okay? Cool. LAN also allows users to store and share large files between each other locally. Okay? So in a local area network, it also allows me to share. That's a key benefit. It allows me to share information locally within my network. I can send data between computers. I can also share printers. So on here, maybe you have a Toinji, you have a printer. And so instead of buying a printer for each PC, if I'm on a LAN, I can send the thing to be printed to my printer, and then we just need one printer. And so our school has that system where we have 3 printers, and I can just send it onto the network, and then the printer will print. Okay? And then previously, without this idea, is you would have to have a printer for each computer, and it would be math. So this is the other benefit. Okay. We're going to do an exam problem right now. I want you to take some time. Uma, can you read the question, and then we'll answer the question together.
The company has multiple sites in different cities. The company has drivers who deliver products to customers. Each driver can connect the company's wiring across without obviously it's not say 2 ways that one is
Okay. So basically, we have a company, and it's a WAN. It says, state 2 ways that a WAN wide area network is different than LAN. Wendy, tell me, what is something different?
in Chinese.
No, in English. This is an exam.
Oh.
State 2 ways that WAN is different than local area connection.
WAN has a large geographical area, but the LAN doesn't have.
Large geographical area. Very good. You get 1 mark. The key difference is a LAN uses a large geographical area. Okay? It could be, for example, from a school to a school or across the city.
Sir, can I say the LA is in the local place?
Yeah, you could, but this question says only LAN. So we can't say LAN. This is only asking questions about LAN. So we have to, we could say a LAN is small, a local area. You can also write that, yeah?
Yeah.
A LAN is a local area. Yeah, that's also correct. A LAN is local, but a WAN is a big area. Okay? Uma, what is one more key difference between a LAN and a WAN?
The LAN is to be owned by the network.
Yes. LANs are usually shared hardware because the infrastructure is so large, it's not everyone can own the cell phone towers. Agree?
Yeah.
So the key difference is a WAN does not use dedicated hardware. It's usually shared
Mr. Newson,
or rented. Yes.
this is fine, only like no dedicated hardware.
可以.
可以。
No problem. Okay? So we have our two answers here. Usually what happens is I give you an exam problem. This is worth 2 marks. And then right here, 1 mark each from the exam. In a WAN, devices are connected over a large geopolitical area. In a LAN, devices are small geopolitical area. Okay? One is big, one is small. Other mark. WAN, they use non-dedicated hardware. Okay? They can all swap the hardware. They can rent the different. When you send signals, it can change the route that it goes. A WAN uses external, not company-owned transmission media. Okay? And LAN, usually you own the hardware. Okay? So if you said LAN, you own the hardware, and WAN is usually rented. It's also okay. Okay? So I think we're okay with that. LAN, WAN, no problem?
No.
Okay. So the last thing is we need to talk about the local area networks, how they're all connected. Okay, and there's different names. And there's also 2 key terms that you need to know. One is called server. Now, what is a server? Uma, what is a server? Have you heard what a server is? What is a server?
服务器
Like,
Okay, tell me, describe
sorry,
what does the hardware look like? What does a hardware server look like? What is he?
server. I want let's say like in a computer game, like the iOS server and Android server,
Yeah.
and it's like it serve for the games.
Yeah.
For some.
You're correct. But what hardware is he? What hardware? Made from what?
It's made of many kind of motherboard and wait for sending information. Made from many kind of motherboard. Yeah.
If we look at this device here, what does this look like? Well, what is he? What is this picture of? Yeah, what is he? What does it look like?
Post the machine.
What does this look like, this box? Have you seen this box before?
Print machine.
No, it's not a printer machine. What is this box right here? What is this box called? What is this box called, Wendy? What is this? What is this called? This is called a desktop computer.
Post machine.
Okay? You have a laptop and desktop. Servers are not necessarily desktops, but basically they are like a desktop, but PC. They are basically a high quality computer that is dedicated to store web pages, and files, etc. So what is the internet? The internet is basically a connection of a whole bunch of desktop computers, okay? So they're gonna have servers that it may not, you can make your own server like a desktop, and you can create a desktop into a server. You can make your own server. Now companies, they have more racks that have hard drives for storage, okay? So they have online cloud farms, and they just have a network. But basically, what a server is, it's a desktop computer that has really good hardware. Okay? And it's going to serve the clients. Okay? What is a client? Wendy, what is a client?
The user.
Yeah, the client is the user. And so what happens is you have to have a good computer to serve you. And this can it can have lots of storage online. Okay? Web pages, any kind of files, videos. When you watch a movie online, it's stored on a server. What is a server? A server is a computer. That's the answer. A server is a super good computer.
So I think the server is. So I think server made by a lot of PC. I think.
Correct. Servers can be one computer. 可以. You can make your own server just one computer. As Chet said, some servers use multiple computers connected together, like a supercomputer kind of idea. Okay? The answer is, okay, client servers are powerful computers to run applications or web services for other people to connect clients. So web servers are basically powerful computers that are used to store information and to have the internet, web pages and stuff like that, okay? So that's what a server is. Now, we have two types of clients, okay? And this is to do with the server. And you should know these, so I would simplify this down. So we have two types of clients. We have a thin client. A thin client is a weak client, not very powerful. It relies on the server to do the processing. For example, Chromebooks. You know Chromebooks? Chromebooks. Chromebooks are a small little laptop, and they really don't have a big hard drive. Maybe they don't even have a hard drive, they have a little storage in there, okay? And instead, they use Google service, Google server. And on Google server, they have all the docs, so you don't need to have too much storage on the laptop, okay? A laptop, like Google Chrome, some tablet, they're kind of pieces of garbage, you know? Like the iPad. You know, iPads are a piece of garbage, right? iPad are,
It is good for drawing.
you know, they're a thin client. They use, you can use more cloud storage because you're not going to have too much there, okay? Now, we have a thin client. It only has an operating system like Google Chrome. Put this right here. As example, Google Chrome. Google Chrome is a type of computer that is really poor, really cheap. It's very cheap, but it relies on the server. This server has to be big because it has to do all the processing. Agree or disagree? One system, a thin client, is weak. Thin means he doesn't have a good brain. His CPU is low. His CPU is a piece of garbage. His hard drive is very low as well. And therefore, he's cheap. He's cheap computer. These are the Kenny computer. Now we have another type of client. It's called thick client. This means that his CPU is pretty good. He has lots of storage, pretty good. And therefore, my database is small because he doesn't need to have the software packages installed on the cloud or on the powerful supercomputer in the network, right? So thick, thin client. You should understand those two things, okay? Thick means it's a better computer. For like example, the desktop. Okay, you install everything and a laptop. Thin client is more like Chromebook, or some sort of tablet. Okay, the CPU is not very good, the graphic card's not very good. They have to do all the processing online, whereas the Uma, in the future, how do you think technology is going to evolve? Do you think we're going to have more thick or thin clients, and why? So do you think that our computers are going to become more powerful or less powerful and rely more on the internet for doing the processing? What do you think? If you had to choose, what would you choose? Do you think it's going to become more thick clients or thin clients? Let me ask a question. Is Google Chrome books, are they a new thing or an old thing? Old? Chromebooks are actually relatively new, and tablets and iPads. And so, in the future, I think that more and more computers are going to become thin clients. Why? It's because they're cheap. And then what's going to happen is, AI, you have to have a whole bunch of servers. In the future, I believe computers are only going to have a display. They're not going to have a real big CPU. You're going to be connected to a supercomputer. You're going to be connected to an AI computer on the internet. And your computer will only, let's say you're playing a game. The game is going to be running on the server. The game is going to be running on the internet, and then it's going to just transmit the game to your screen. Okay? So this is my hypothesis that in the future, technology is going to become cheaper because your computer will not have a big hard drive. Your computer is going to have a garbage CPU. The technology is getting cheaper is because they're putting less technology in it. Where are they putting the money is on the servers. And so in the future, server or supercomputers may be big as the whole room. Okay? We have quantum computers now, right? They're so big. Not everyone can put that in your pocket. And so what's going to happen is you're going to have a thin client device that will have no CPU, very poor CPU, right? Very slow. And it's only going to run what is running on a virtual server. Does that make sense?
No, we don't need it. Maybe it's much smaller, like a watch.
Maybe it's going to be like a watch. You can go any size out, because what is a big problem there, Wendy, right now with computers? There's a big problem with technology. Is technology getting bigger or smaller? Yeah, right now, computers, they're become so small. Okay? The microchips are getting so small that they're having problems now. Could you just have a look here, Uma? The issue right now is when on the CPU we have the bus. And it's getting so small that the wires, it's getting like small like atoms. And we're studying electrons. But as the electrons moving, we have this thing called magnetic field. And this is called crosstalk. is when I send an electron here, some of the electrons are going to be induced in another wire. This is called cross talk. It means that as I'm communicating down a wire in the CPU, the wires are so close together that it induces current on another wire. Because we're like atoms apart, right? Can we go any smaller? We're reaching a limit. There's this thing called Moore's Law. Moore's Law. I'm not sure if that's how you spell it, but it just says that every year things become 2 times faster, 2 times smaller. Have you heard about this? The 2 times effect? Moore's Law is saying that technology is a function. Storage is increasing every year by 2. Okay? You see that? Is there a limit, or are we reaching the limit of technology? And so this idea of thin client is, in the future, your devices are getting too small. So we're going to have to go big. Let's make a big supercomputer, and our small devices will connect to the big computer. Interesting. Okay? So we're reaching the limits of what technology can do these days. Okay. Topologies are like how things are connected. Okay. Very first one, point to point. All I want you to do is draw a little picture. PC, PC. Okay? This is called point to point. That is the most simple network. Okay? Did you copy Hala? Point to point is the very first typology.
Wait, let me have a look.
Yep.
What?
Topology. It's basically how devices are connected on the network. How they're connected on the network. Number 1 is point to point. Number 2, it's called the bus or ring. The bus or ring, you have, so number 2 is like the bus / ring, okay? And what happens is you have a common bus line. This is a terminal. And this is the bus line. And this is your PC. This is called a dumb network. Is because there is no central hub. The data or the packets are transmitted to all the computers. And then this looks at the IP address. Okay? So in this, there's no router. Data, what is the other word for data on the internet there, Uma? What is the other name for data that on the internet? When you send data on the internet, they send them in what? Into packets, yes. So, other word for data is packets. Okay? Data packets are sent to all devices. Okay? And so it's not very efficient because he doesn't know who to send. There is no router. The data goes to everybody. This wastes time, okay? It does waste time and it's not very secure. It wastes some time and it's not secure. Because if I'm sending a picture, it means that you guys all see my picture, right? Well, it's going to delete the file. What's going to happen is the PC will say, oh, this data is not for me, and so he just throws it in the garbage. But if you have a sniffer, a packet sniffer, you could actually steal this data, okay? So, and the reason why they call it a ring, the bus can also be connected in a ring, where you have all the computers connected onto the bus, okay? And the data just kind of goes around in a circle, okay? They call it ring and bus is just because they did it in the shape that it is. It can go around like that, or it can be just on the bus right here, okay? So this is the second type of network topology. The very first one is point-to-point. That's the most basic, 2 computers. The second one is called bus or ring. It does not need a router. It's very low. We don't see it too much. Okay? It usually doesn't exist anymore. All right. Mesh network, number 3. Please do draw a picture. Mesh network, it just means that everything is connected everywhere into a mesh. This is called a mesh. There's direct wires between each device. There's one problem with this. What is the problem with this one there, Wendy? What's the problem with the mesh network?
2 components.
Yeah, it's a lot of wires. It's a waste of wires. Okay? But if your router, back in the day, routers were really expensive. The hubs were expensive, and so wires were cheap. Okay? So we had the mesh network. Now we're coming to the star network. The star network looks like this. At the center we have a switch / router. And then they call it a star because you connect all your devices to the central PC or a hub, router or hub, like this. And then in here, you're going to have your modem. And then you're going to have your internet. Okay? This is going to go to the servers. You can, the reason why they call it a star is because it looks like a C. Okay? And how does this work is all devices communicate with your switch. And the switch router, they look at your IP addresses. Okay? So all devices are connected to a common hub or switch or router. And the good thing about this is if one computer dies, what will happen to my network there? Come on. If I have a star topology and a computer dies. Yeah, but if one PC dies on this, it doesn't matter. The network will still work. Okay? One bad thing is, though, if my router dies, then it won't work. Some good things about this is there is no router there, so you have less hardware to fail. Right? So each one has some good things and some bad things. Good. And then the last one, number 5, is called the hybrid one. Maybe you have some, what is this called there, Ched? What is the name of this guy?
Server.
No, what typology? This is 3. There's 3 networks here. What are the names? Yeah.
Bus.
This is bus or ring. Ring. This is star. And this is called bus, or peer-to-peer. Yeah. So you can put all of them together. Which, Wendy, which network is most common today?
I think maybe it's
Who's the winner?
hyper.
No. Who's the winner? What is the most? Yes. Today, 90%, 99% of the entire world uses star. Why? Because you can just connect it with the wire. You know, it's very easy to plug in. The routers are cheap now. A long time ago, routers were expensive, switches were expensive, so this was more popular. This star is the most popular now. Okay? Why? Routers and switches are cheap. Before they weren't. Okay? Yeah. Okay, this is it. Exam question. Wendy, can you read the exam question?
The main office for the company has 4 wire computers, 1 server, 2 printers, a central switch, and a device providing a single point of access for the internet. The network is set up as a star topology. Draw the topology for the main office network. Label all devices.
Very good. When you have a word problem, Chad, what is the first thing you should do? This is an exam.
Draw a picture.
No. What is the very first thing when you read the problem? What is a good strategy? When you read it, is circle the key information. We have 1 server. You can highlight or circle on the test paper what is the join-all information, what is important. We need to have 1 server. Agreed? We need to have 2 printers and 1 switch because, Uma, how many things could I put in the center? Do I always have to have a switch in the center of a star topology? What could be there? It could be a hub, or it could be a router. But this says you must use that hardware. There's no option. Okay? And a device for a single point of access to the internet. So this means that we need to have a modem. Agree? And what is the last important information there, Wendy? What is the last important information that we need to draw? What type of topology is this network? Star. It's a star. Those highlighted things I want you to quickly draw. Okay? And then show me. And that's it. Okay? Your schoolwork is 3.1, but I want you to draw this and we'll see if you're correct. You need to draw a star topology with 2 printers, 1 server, 1 switch.
How to draw?
I'm not that drawing.
How to draw a star topology. Have a look in your notes. You can also.
Today's note.
Is I'm ready here? Does it show on the Teams? Can you have a look?
Today's note.
Is it updating? If you go on the site, can you see here? Can you see my rate? No? Oh. I thought my rate is
Just
good.
today's note.
That's it, yeah. So, try this exam question. You need to have 1 server, 2 printer, and 1 central switch.
So what's the picture we would like?
And then where's the internet?
So is the
Do you have the internet? You need 1 single point for the internet. Where's the internet?
So is the picture we would like this? Or I should draw
Star. What does star look like? Icing?
oh,
This should look like a. No.
like this, right?
Look at the. the star. Can you open up the notebook? So when I'm talking up here, you can have the notebook on your computer. Okay? So I'm just going to use the PowerPoint here, so you need to look at the picture.
Notebook.
Oh, it has 4 computers. Don't forget, it has 4 computers.
3本书对吧？3 books.
Yes.
3 books and
Unit 3.
library.
Yeah. Unit number 3. Networks. And 3.1. Yeah. Can you go to Window and click on 3.1 up here? See if you can see my rating. Yeah.
Oh.
Yeah.
I see.
Okay.
Sir, I can't see.
Let me just. I'm gonna pause my recording here. Okay.
Sir, there is a PTA